We're asked to figure out the voltage at this node X. So how can we do that? Well, as we can see, there are a few things indicated. We can see that 8 volt is indicated at this node, and there is 9 volt indicated at this node, and there is 1 ampere of current flowing in this branch. At first, this entire circuit may seem a bit complex, but it's actually quite easy. We know that according to Ohm's law, the voltage drop across the resistor is the current flowing through that resistor multiplied by the resistance value, right? So we can see that 1 ampere of current is flowing here. So we can instantly get the voltage across this 3 ohm resistor, which is 3 volt. Okay, now what exactly is this 3 volt? We know that that is a drop or the voltage seen across this resistor. So we can say this 3 volt is actually the difference between two potential as well. Suppose this node is A and this node is B, and I'm calling the voltage at this node VA and the voltage at this node VB. We can say that VA minus VB is equal to 3 volt. And why VA minus VB? Because the current flowing is indicated as flowing from VA to VB. So we take VA minus VB. From this equation, by doing basic algebra, we can obtain VB value. If I take this 3 volt and subtract it from VA, I would obtain VB, and VB is equal to 6 volt. And now that we have this 6 volt here, we can subtract that 6 from this 8 volt to get the entire voltage drop across these two resistors. We can see that the both resistors are in series, so we can combine them and make a single resistor. And if I take the entire drop and divide it by the resistance value, I would get the current across this branch, which is 2 by 3 amperes. Now there are two methods in which we can obtain the value of voltage at X. One would be that if I take this 2 by 3 ampere and multiply with this resistor and obtain the voltage drop across this resistor and add that value to this 6 volt, I can obtain X. In the same algebra, we take Vx and we take Vb. We don't know Vx, so we add the drop to the Vb and we get Vx. Similarly, we can take the 2 by 3 amperes and multiply with the 2 ohm resistor and obtain the voltage drop across this resistor and then subtract that value from this 8 volt, just like we did here. So either way, we're going to get the value as 2 by 20 by 3 volts.